The area of rectangles and the area of triangles are pretty closely related. A rectangle, as we know, is area is equal to length times width. And a triangle is really half of that because it takes up half the space, except the triangle doesn't really have a length and a width because it only has three sides. So instead of thinking of it as area times length times width and dividing it by 2, we should instead think of it as 1/2 of the base and whatever the height is that comes out of that base. Now, a height has to be 90 degrees, perfectly straight, from the highest point to the lowest point. So for instance, as I look at this first one on the left here, I see that that's the highest point and it comes straight down here to this corresponding base. So if I were to find the area of this rectangle, I know that area is 1/2 of the base times the height. I know that 1/2, I can see that this base that's given is 20, and the corresponding height, which they measure over here, is 15. Now, because of commutative property, I can do this in whatever order I want. I would probably do half of 20 and make it 10, and I know that 10 times the remaining 15 is an area of 150 centimeters squared. So there's two more that are just like this. I'm gonna pause the video here. You should pause the video here, and then we can go over them after you pause. Okay, we look at the second one. Again, I know area is 1/2 of the base times the height. I know that the base of this shape is 14, and its corresponding height, which they measure on the outside here, is 12. Now, I know that height is not a side of the shape, and that's okay. It's just the distance from, as we said earlier, the top point to the corresponding base. When I continue this, I do half of 14, which is 7, and 7 times the remaining 12 gives us 84 square feet. For the last one, they give you too much information, but I can clearly say that the height is from the highest point in a 90-degree line down. So the height here must be this 13, and its corresponding base looks like it's 20. So area is half of the base times the height. That's 10 times 13, and it's an area of 130 square meters. Now this piece right here I don't even need. This is a side. Now maybe if I were doing perimeter, I would need that, but I don't need it here. The areas of these triangles are really no different. If I look at this one, I see that there's a base. The only difference now is that the base and the height don't connect to one another. If I look at this highest point here, it's got to be 90 degrees down. Problem is, it doesn't go over top of what looks like a base. This 90 degrees here comes straight down here, but it doesn't match with the corresponding base, which is here. But that's okay. As long as I know the length of this base and its corresponding height, I can find its area. Area is 1/2 times the base here, which is 8, times the height, which is 3.6. Half of 8 is 4, and 4 times 3.6 is 14.4, in this case, inches squared. If we look at the other two, you can pause the video here, try those two, and then we'll go over them. Okay, for this first one, I see this is the highest point. It drops down at 90 degrees, so that must be my height. Here's the corresponding base, and even though they don't connect, it's still the base and height of this triangle. Area is equal to 1/2 of the base times the height. The base is 9. The height is 8.4. Half of 9 is 4.5 times the height, which is 8.4. Now this one you probably have to get a calculator for. You can do the work, but if you get a calculator, you'll see that the area is 37.8, in this case, meters squared. Over to this other one, same formula. Area is equal to 1/2 of the base times the height. Here's the highest point. There's my height. It's outside the shape, but that's okay. Its base is right down here at 10. base is always a side. So this stuff along the side in both cases here, this stuff here and this stuff here, it's not really part of the base. It's just extending it so you know where to draw the line to from the height. If you plug in, area is equal to 1/2 of the base, which is 10, times the height, which is 4.8. I might do this part first because I know 10 times 4.8 is 48, and then I know that half of 48 is 24. So the area here is 24 square feet. These problems are a little bit different because in both cases, what you'll see is that they give you the answer. They give you the height. So you have to use algebra to work backwards to figure out what the missing height is. We have a couple of important things that we need. They tell us the area. They also give us the base. What we should see is it's the height that's missing. So if I want to do this, I know I can use the same formula. Area is equal to 1/2 base times the height. They give me the area is 60 is equal to 1/2. They give me the base, which is 16. And they do not give me the height. So I'll solve what I can. I can do half of 16. 60 is equal to 8 times the height. Now I'm almost done. If I think back to algebra, I've got 8 times h is 60. I want this variable alone, so if I divide both sides by 8, I'll see that the height ends up being 7.5. I can always go back and check it too. If I do 1/2 times 16 times the height that I just found is 7.5. Half of 16 is 8. This ends up being 60, and it matches with where I started from. If I try this one, it's the base that's missing instead of the height. I see that they've given me 135 for the area. What they haven't given me, gave me the height. What they haven't given me, what's missing, here is the base. But I'm going to use the same formula. Area is equal to 1/2 of the base times the height. The area is 135. It's 1/2. I don't know the base, but I know the height is 18. I can do half of the 18. 135 is equal to 9 times b. And if I divide both sides by 9, I'll see that the base ends up being 15, in this case centimeters. It's not squared or anything because it's one of the sides, but I just would probably use my calculator for this to try to work through it. Here are 4 problems you can try where in every case 2 of the 3 things are given. For this first one, they give me the area, they give me a base. The next one under here, they give me the area, they give me a base. Over here, they give me an area, and they give me a height, and an area, and they give me a height. But in every case, area is equal to 1/2 of the base times the height. I'll pause the video here, and you can try these 4 problems, and then we'll go over them. Okay, for this first one, I know that the area is equal to 1/2 of the base times the height. Looks like the area is 300 is equal to 1/2. It looks like the base is 30. The height is not given. 300 is equal to 15 times the height. And if I divide both sides by 15, I'll see that the height here is 20 centimeters. If I look at the one underneath it, again, I know that area is equal to 1/2 of the base times the height. They give me the area is 198. It's equal to 1/2 times the base, which is 16.5, times the height. I would use my calculator for this part. 198 is equal to 8.25 times the height. And then if I divide both sides by 8.25, again, I'd probably use my calculator for this, but if I do it correctly, it'll give me that the height of this shape is 24, in this case, feet. If If I go and try this one over here, again, the area is equal to 1/2 of the base times the height. They give me the areas 72, 1/2. They don't give me the base, but they do give me the height, and the height here is 9. 72 is equal to, I can do this part, 4.5 times the remaining base. If I then divide both sides by 4.5, and I would use my calculator here, B is 16, in this case, centimeters. And if I try the last one here, I know area is equal to 1/2 of the base times the height. The area is 113.4. It's equal to 1/2. The base is not given, but the height is 16.2. If I take half of 16.2, it gives me 113.4 is equal to 8.1b. And then my goal is to get the variable by itself. And again, I would probably use my calculator for this. If I do my division correctly, it's 14, in this case, meters, and not squared or anything because it is one of the measurements.